All right, by now you should be done your warm-up. Today we're going to do a warm-up, a little bit of guided review notes for tomorrow's test, and then a bit.ly at the end. So, warm-up, number one, at Food Lion, a dozen donuts, dozen is 12 donuts, are on sale for $6.98. Which equation would be used to determine the cost, C, for any amount of donuts, D? Well, C and D we can automatically eliminate because we know 12 donuts are for $6.96. That means one donut can't cost anywhere near that, so they must be 58 cents. Well, from there we have to plug in some values and just see which equation holds true. A is saying that the donuts are the same as 58 cents times the cost. So 12 donuts should equal 58 cents times $6.96. Well, I know when I multiply something less than 1, that number is going to get smaller. This is about a half, so half of 6 is 3. So that eliminates A. Well, B should be the correct answer, but let's just verify. 58 cents times the number of donuts, 12, should tell me the cost, $6.96. Well, 58 cents is close to about a half a dollar, and half of 12 is about 6. So we could say, even if we're not sure on the math, process of elimination, a little guess and check, B would be the best answer. Number 2, which of the following would best represent the expression 1.25n? So we're trying to find an equivalent expression from one of these scenarios listed below. A, n is being discounted by 25% of n. That would be 0.75n, not 1.25. Well, B is also incorrect because this is a mark down, which is also a subtractional fee, down by 75% of n, which would be 0.25 of n. Again, not what we're looking for. D, n increased. Okay, we had something that's going to be greater than 1. 125% is 1.25% n. Here we get 2.25 n. Still not our answer. Let's just make sure that C would be the best answer. N increased by 25% of n gives me 1.25 n, which would be answer choice C. The item's been increased by 25%. Number 3, C. Just so you know, all the answers were wrong in the warm-up. We had an accidental mistake here. So 2 cities, very different elevations. The city of New Orleans is located at 42 feet below sea level, so that's negative 42. The city of Charlotte is located at 132 feet above sea level. So I know that that is a positive or an additional thing, 132. And they want to know the distance between these two. Well, I have different signs. Different signs subtract. Take the sign of the larger side. So really this is 132 minus 42, which gives me 90. I have way more positives than I have negatives, so that makes it positive 90. And I'm pretty sure you could have seen we meant D to be not negative 90, but positive 90. Number 4, a ticket problem. Right here, they give us a scale. 1/2 inches equals 5 feet. So I know my ticket would be inches to feet. My ratio, 1/2 over 5. Same as, well, 1 1/4 inches. 1 1/4 inches. We don't know how many miles. Cross multiply, we get 1/2 x. 5 times 1/4 is 20 over 4. If you got a mixed number in your calculator, I'm sure it's equivalent to the same. We're going to divide each side by 1/2. If you weren't having a calculator, it'd be 20 over 4 divided by 1/2. Keep, change, flip. Or I'm sorry, 25 over 4. Keep, change, flip. We get 2 over 1. We'd get 50 over 4. Calculator would reduce that down to 12 and 1/2. Okay, so either answer, 50 over 4 or 12 and 1/2. Okay, into some notes for today. So, number 1, you have a section for area and a section for circumference. Let me bring up all our options. We're going to sort them in there. You can take some good notes on this and definitely make sure that you have these to use for the test tomorrow. So, right here. Okay, we're going to sort these words into either area problems or circumference problems. And we got to think about the parts of a circle that it's talking about. Well, I know the first one, apples to fill a pie. Well, I put apples inside my pie, so that must be talking about the inside area of a circle. Second one, the amount of crust on a pizza. Well, I know crust goes around the outside of a pizza, so that must be a circumference problem. Third one, the paint on a Frisbee. Well, I paint the inside of the Frisbee, so they must be talking about area, the inside of the Frisbee circle. Distance around a track. Well, this keyword around means they're going around the outside of the track. That would mean it's circumference. Cheese on a pizza. Well, I know I put my cheese on my pizza in the middle of the pizza, so that must be an area question. The size of a plate. Well, they measure the size of a plate by how much space it covers on the inside, so that again must be an area problem. And then the last one here, dirt to fill around the garden. Again, we're filling just the outside of a circular garden, so that must be a circumference problem. So take a couple seconds, even if you have to pause the video, make sure you have these filled out so that you have them to use later today and tomorrow. Okay, moving on. We're going to get into a couple of review questions here quickly. So on the board, it asks for the area and the circumference of each circle. Well, let's make sure every single circle problem, the first thing you should be thinking about is what information is given to me. Do I get a diameter or do I get a radius? In this circle on the left, that 8 goes straight across the middle from point one side of the circle to the other point on the other side of the circle. So that must be my diameter. Radius is half as big, so it's half of 8, which is 4. Again, if you wanted to draw it in there, you could. That way, if you have it, you need it, visually you see it. We have two things we got to find, the area and the circumference. Well, our area formula, area is the same as pi times the radius squared. I already have my radius waiting for me, so area is going to be the same as pi 4 to the second power. At this point, I would pick up a calculator, make sure you're getting the same answer as I am. So pi 4 squared, pi 4 to the second power is going to give me roughly 50.2 units squared. Second problem I want to solve is the circumference. Well, I know I need my formula. Circumference is the same as pi times its diameter. Again, I have my diameter listed, so that makes this problem easy. Pi 8. So again, let's pick up a calculator. Let's do pi times 8. The circumference should be roughly 25.1. Okay? So again, circumference, we're talking about the distance on the outside of this circle. Area, we're talking about the middle of the circle. Second example, again, they gave us a diameter, cut straight through the circle from one point to the other. The radius is half as big, so it's half of 14 or 7. Area, again, we got to know our formulas, pi radius squared. So to find this, pi times the radius to the second power. So again, pick up a calculator, let's see what you get. Pi 7 to the second power gives me roughly 153.9. Again, units squared because we don't have any units. Second part, circumference. We know that we use our formula C equals pi times diameter. Again, I have my diameter listed, so it makes the problem very easy. Pi times 14. Again, I pick up a calculator. Let's see what pi times 14 is. Should have got 43.9. Take a second, make sure you got everything on their slides written down before you move on to the next one. Next one, let's look at a couple word problems. So this goes back to those common words that we took notes on at the very beginning of this. The first one, a large pizza from Domino's is shown below. So here's our large pizza. What is the area, okay, this one's nice because they literally said the word area, of the region that has pepperoni? Well, I know there's only one slice with pepperoni and they broke it into 4 slices. They give me the diameter, which is 16. So again, I know my diameter is 16. My radius is half as big. It would be 8. But this is an area problem, so I'm going to go ahead and cross that diameter out because I'm not going to use it for this problem at all, and I don't want it to confuse me. Next up, since it said area, I'm going to use my area formula, A equals pi r squared. Again, I have my radius waiting for me, so pi 8 to the second power. So again, pick up a calculator, pi 8 squared. You would get an area of roughly 201.0, okay? But we got to think to ourselves, we have an area formula that tells us the area of an entire circle. Well, this circle was split into 4 regions, and since I only want the area of one slice out of the 4, that means I have to take my answer and divide by 4. So 1/4 of the area, 201 divided by 4, means that each slice is roughly 50.2 square inches. Okay, 50, 50, 50, 50, about 200. Okay. So again, if we have a circle and it's been broken into multiple pieces, we just have to divide by the number of segments or the number of slices. Number 2, a birthday cake has a radius of 7. Well, that's good to know, so I'm going to go ahead and draw my radius line, label it 7. Well, once I know my radius of 7, I also know my diameter of 14. Keep reading, because I'm not sure yet which one I'm going to use. A family ate 1/2 of the cake, so right here, they're going to end up eating just half of this cake. We want to see what is the total area that the family ate. So we want just the area of just half of this pizza, or cake rather. Again, they said the word area makes this problem real easy. A equals pi radius squared. Again, I have my radius waiting for me, so I'm going to cross out that diameter so I don't accidentally plug it in. Pi 7 to the second power. Again, pick up a calculator. Pi 7 second power. That means the area of this cake was 153.9. But again, our formulas tell us an entire area or an entire circumference. This area is for the whole cake, but they only ate half of the cake. And we want to see how much area they ate. Well, since I need half of that number, I need to divide this by 2, and I'd find out that half my area was approximately 76.9 inches squared. And again, if this side's 76.9, the other side's 76.9, it has a total of 153.9 square inches. Okay, again, before you can move on to the next slide, make sure you have all good notes so that you can use them for tomorrow's test. Next slide. Okay, now we're going to get into some new stuff. We covered this on Pi Day, so for those of you that were here on Pi Day, we actually did a couple of these problems, but let's go over them again. This question wants to say, what is the distance around this figure? Well, if I think to myself, what information do we know? We know that it has a length of 11.5 and a width of 10. I also know that I have a semicircle, so it's asking me what shapes make up this figure. I have a half circle and part of a rectangle, because if I'm only talking the outside, again, if I walked around, if I thought about this maybe as the key of a basketball court, and I wanted to see what's the distance around the key, I would have 11.5 feet by 10 feet. Well, if I go up here, these sides are parallel, so they must be the same. And then I'm going to walk around this curve, and I'll even change colors just because this is a little bit trickier. We know that this is perimeter, that we can add these 3 sides together on the rectangle. So I know that for the parts of the rectangle, I have 11.5 plus 10 plus 11.5. But I have to think to myself, how can I find the distance around that circle? The distance around a circle is really a circumference problem. Now, if I wanted to dot this in and kind of see this as a whole circle, okay, I would see that this line must be a diameter because it goes straight through the circle from one edge to the other edge. Well, they didn't give me a diameter, but they did give me a parallel congruent side. So if the bottom's 10, the top is also 10. Now I know my diameter's 10, my radius is 5, and I want the circumference. So again, I'm going to cross that radius out just because I'm not going to use it. If this was an area problem, I would cross out the diameter. C equals pi times the diameter. Okay, so I have my diameter waiting for me. C equals pi times 10. That means the circumference of this circle would be about 31.4. Well, here's again the problem. I don't have a full circle, so I don't need the full number. I need half of the number. So again, I'm going to divide by 2 since I have a semicircle or a half circle. And I'm going to find out that half the circumference, 31.4 divided by 2, is going to be about 15.7. I'm going to take that 15.7 and I'm going to write it up here on my semicircle. And then I'm going to go back to my original drawing where I traced around it. And I'm going to switch over to blue now that I have all the values I need. And I'm going to think about what parts of this picture do I actually need. Well, again, I have 11.5. If I walk across here, I went 10 feet. If I go back up this side, I got 11.5 feet. And now that I know when I walk around this curve, I really went 15.7. So that's the extra number I need here. Let's think about this. Why am I not going to end up adding this extra 10? Well, that's the distance on the inside. So that 10, although it helped me find the diameter, has nothing to do with the actual perimeter or circumference of that semicircle. Once I know all the numbers on the outside, I just add them together. So I'm going to do 15.7 plus 11.5 plus 10 plus 11.5. In my calculator, 15.7 plus 11.5 plus 10 plus 11.5 would give me a total perimeter of 48.7 units. So again, not that hard. Perimeter, that's a 6th grade, 5th grade concept. Semicircle, okay, a little challenging. Just make sure you divide by 2. Down below, we have one more example. All they did, same exact problem. It says determine the circumference. It should really say the circumference or the distance around the entire figure. Well, again, let's kind of start taking a peek. Well, I know I have some dimensions. I'm going to fill in what I can, what I know is true, just on congruent sides in geometry. Well, they give me a value on the bottom of 6. Well, I know the bottom and the top are going to be the same, so I'm going to label that 6. They give me a value on the right side of the rectangle, which is 8, but the left is blank. Well, I know the left and the right are the same, so I'm going to go ahead, again, just kind of break down the problem, add some information, and think about what's relevant and what I need. Well, I know that when I travel around this part of the basketball court, I went 6. I traveled down, I went 8. I travel back across, I travel another 6, but then I get to yet another semicircle curve. So again, I got to think to myself, how can I calculate the distance around the curve or the circumference? Well, again, if I was to dot this in and picture this as a full circle, I would see that 8 in the middle is quite clearly the diameter. So if I know the diameter is 8, I also know its radius is 4. But again, they're talking circumference, so I know I need C equals pi times the diameter. So c equals pi times 8. We'll find that circumference, pi 8, gives me a circumference of 25.1. But again, that would be the circumference if this was an entire circle, but it's not. It's only half of a circle. So again, I only need half this number, which means I have to divide by 2. That means half my circumference would be approximately 12.5. Again, I'm going to take that 12.5 and go ahead and plug it back in. And then again, I'm going to revisit the original drawing, and I'll even change colors again to kind of take a peek at this. Well, again, I know that if I go up top, I went 6. Down, I went 8. Over, I went 6. And now when I go around this curve, I know that it's 12.5. So that would be the last number that I need. I'd have to add 12.5 to the perimeter of the 3 sides of the rectangle. Again, I'm going to cross this 8 out so that I don't accidentally add it in there, because that 8, again, my diameter, does great things for this circle, but does not help me with the perimeter of the entire shape. Again, we pick up a calculator, we add all our values together, 6 plus 8 plus 6 plus 12.5 would give me a total of 32.5 meters. Again, that would be the total distance that I outlined here in red. Okay, again, make sure before you move on to the next slide that you have all your notes down. Last two, before we get into a couple trial problems. Determine the total distance around the figure. Well, very similar to what we just did. The only difference is now they're actually giving me something that looks a little bit more like the track. So if we think about this, this would be like the Coolwood track. We got the football soccer field here in the middle, and we got the sides of the track that goes all the way around the whole thing. Well, if I think about this, I'm actually going to go ahead and put a little person right here on this track to help me out. And we're going to walk around this track and we're going to think about, well, what parts of the track are they actually going to calculate? Well, again, if I go across the top here, I go 30. Okay, so I know that I have a 30 here inside that rectangle. When I go around the curve, I'm going to have to calculate some kind of circumference. This, I'm not sure about. But I know when I walk across the bottom that the top was 30. That means the bottom must also be 30. So again, I'm going to know that I have 30 plus some 30 plus this curve that I don't know about, and if I walk back around to get back to where I started, I got to go around another curve. So I end up having to need a value here for these two curves, okay? So again, I know that I see a rectangle in the middle, and I see a semicircle on the left and the right. Well, if we take two semicircles and combine them, we really just have one circle. So I'm going to draw one circle, and I'm going to put the line in the middle. They gave me a value of 15. Well, obviously now, once I combine my circles, that 15 is pretty obvious. It's our diameter. That means our radius is 7.5, half as big. But again, they're talking about the distance around. Well, I know when they talked the distance around, we took some notes on that. We talked about the distance around a track. That was really a circumference problem. So C equals pi times diameter. Again, I have my diameter, so I'm going to cross out my radius. C equals pi 15. Okay, so again, I'll pick up my calculator because I have to calculate that. Circumference is about 47.12. Okay, now we got to think about this. This 47.12 represents both semicircles. So I'm not going to label them both 47.5 because they're combined 47.5. This side plus this side, half circle plus half circle gives me a full circle, and my circumference always finds the distance around a full circle. Well, the problem is, if I want to make this out so that I have all my numbers touching the outside, I'm going to have to break this in half too and put half the number over here, half the number over there. So again, I'm going to take my circumference, I'm going to divide it by 2. So 47.12 divided by 2 means that each side's about 23.5. So now I'm going to go back to that picture. I'm going to label this side 23.5. I'm going to label this side 23.5. And then I'm going to walk my guy around the track and think about, well, what numbers does he touch? Well, here's my guy. He walked 30 yards. He went around that curve. He walked 23.5. So I got to add 23.5. He walked down across the bottom. Well, there's another 30. There's my two 30s. And if he walks back around and gets to the finish line, he added another 23.5 yards. Again, once I have all my values, I'm going to cross out that 15.5. Again, helps me with the circle, has nothing to do with the inside, or sorry, the outside of that picture, since those 15s are located on the inside. Once I have all my values, 30 plus 23.5 plus 23.5 gives me a grand total of 107 yards. That means if they were to walk around this track they would go 107 yards. And that actually makes pretty close sense because the distance in a football field is 100 yards, but there's the end zone, so it's only really 100 yards from here to here. Well, those curves, a couple extra yards to walk around. Okay, so really not any different than what we just did in the previous examples. The only difference is we had two semicircles, so we had to find the circumference of both, break it apart, but we're actually going to use both halves on this one. Last one before we get into a little bit of a bit.ly, some practice problems. Up here, this one, very similar to the one we just did. The only difference is I actually kind of made it into a scenario. So, an ice rink needs to run a protective border around the outside of the ice rink. What is the total yards of the protective border that they need? So right here, they're talking about the outside distance of this figure. Well, I know outside means perimeter or circumference. In this problem, again, first thing might be a good idea, let's label some knowledge. We know that the top's 40, we know that the bottom's 40. We know that the right is 30, so the left is 30. And then again, if you have to put a little person on the edge of the boards and have him walk around and think about what values they passed, good strategy. So let's walk the guy across. I know when he travels this far, he went 40 yards. And when he goes across the bottom, he's going to go another 40 yards. But when he goes around these curves, I'm going to have to calculate something. Because curves, we're talking circumference. So again, I know I have my circumference formula. C equals pi d. I know that if I take these two semicircles and combine them into one big circle, that 30 is clearly my diameter. So I know my diameter would be 30. I know my radius would be 15. Since this is a circumference problem, I'm crossing out my radius and using my diameter. C equals pi times 30. Again, I would pick up a calculator, pi 30. I'd find out that those circles have a circumference of 94.2. But again, that's the entire circle. And I need to know the distance around just the semicircles. So I'm going to take that answer, divide it by 2. That means half of each circumference is 47.1. Again, I'll go back into my picture. I'll label what I now know. This side is 47.1. This side is 47.1. Anything on the inside, I'm just going to cross it out and not get confused by it. And then once I again walk my guy around the track, he went the rink. He went 40, 47. Ooh, he just decapitated. 47.1, 40, and another 47.1. So if I go back to my original problem, I had 40 and 40. I need my two 47.1s. Again, last step, I pick up a calculator. 40 plus 40 plus 47.1 plus 47.1 gives me a total of 174.2 yards. Okay? So again, when we see one of these complex figures, all we really need to do is break it apart, think about what parts are relevant, walk a guy around a track, a rink, something that represents that picture, and that's it. We combine all our totals and we find the perimeter. Hopefully you found this video to be helpful. At the end, you will find this bit.ly. There are 10 questions. They are very similar to tomorrow's test, so what you get on this bit.ly should be roughly around what you scored tomorrow. Just show your work below, and that's all I got for you today.